Okay, good morning again. Today we're going to start chapter 7, moving to larger systems. If you remember, since we started the first day, chapter 1, we were talking about microcontrollers in general, but mainly we were covering the 16F877A microcontroller. And this microcontroller, we said the 877A microcontroller, the larger system, is backward compatible with 84A. So we were learning the theory and what's in the 84A controller, but we did not have the chip, the actual MCU, and we were implementing everything on the 77A controller, but pretending that it is the 84A controller. Now, we almost covered everything in the 84A controller, but there are still many topics in embedded systems we did not cover and they're not present in the 84A controller. So we're going to move now, we build the foundation on the 84A, and now I'm going to show you how is the 877A different, what's new here. So the main differences between the 16F877A controller versus the 16F84A controller are: one, in the program memory. Well, it's not a comparison. Program memory. And by the way, all these notes I write every time are here, and I have them, and I can convert them to PDF and give them to you, but I'm not sure if they're going to be useful or not. Anyways, okay. So first thing, we're going to see how program memory is different in the 77A controller versus the 84A controller. We're going to cover how is the data memory different. We're going to talk about extra peripherals that present in 77A and not there in the 84A. We're going to talk about extra parallel ports. Okay. And the last thing is interrupts, the differences in interrupts. Why are these important? You know that the 84A controller has only 1K program memory, right? And if you remember, when we talked in the beginning of the semester, we talked about this here. We know that the 16F878A controller had a 1K program memory, actual program memory, while it had an address space for 8K, if you remember, 68 bytes of RAM, and had these peripherals. And for interrupts, it had support for 4 interrupts. The 77A controller, however, has 8K of program memory, and this is dealt with differently, okay? So we're going to see the differences. 368 of data memory. We're going to see the new architecture here, how it's different, the many new peripherals, and the interrupt capability for more interrupt sources, okay? So these are the new things we're going to cover when talking about the 7A microcontroller. Why is this important? When you have 1 kilo memory, it could be not enough for certain kinds of embedded systems. So we need to learn how to deal with larger systems. And here we're going to talk about pages, program memory pages, data memory banks. Okay, we have more banks. Here we have more peripherals. We have serial communication. The 84A controller does not have serial communication, okay? So I'm gonna cover in this course, in the extra sessions, serial communication. It's not present in the 84A controller, it's here in the 77A, so we need to look at it. The analog to digital conversion, it's the 84A does not have analog to digital, 77A does have these under peripherals. Parallel ports, 84A had only 2 ports, port A and port B, while 77A has port A, port B, port C, port D, and port E. Interrupts, this had support for 4 interrupts. This has support, I forgot the number, however, it almost covers all the peripherals in addition to that, those 4. By the way, before I forget, last time we talked about timer 0, that it cannot wake up the microcontroller from the sleep mode, and there was a concern if, like, okay, if the clock was not the oscillator clock, if it was the external clock, will it still not awake it, or it will? So searching around and looking at the data sheet, it is explicitly spelled out here that timer 0 interrupt cannot awaken the processor from sleep, since the timer is shut off during sleep. It is shut off, the timer. It's not about the source of the clock that increments the timer, okay? Here's the timer. And the synchronization 2 cycles here, this is part of the logic that stops, okay? Anyways, I just remember that. Mashi, so we're gonna cover the differences between the 77A controller and the 84A controller, and let's go start looking at these differences. And here I'm gonna be practical and try to be fast, just to cover the things that we need to build on when we talk about A to D, when we talk about serial communication, when we talk about larger programs. Mashi. The first thing is in the packaging. The 84A controller had 18, I think, right? 18 pins. Wallahi, I think it was 18. Was it? The package? It was here. Yeah, 18 pins, right? The 84A controller, it was 18 pins, the pin layout. The 77A, well, this chapter is talking about larger systems, 74A, 73A, 77A, okay? We're going to the largest one, okay? So we're gonna be talking about the 77A controller. So we're here. That is 40 pins. And this is the one we use to do our demos, and the one I have here on my board. So it has 40 pins versus 18. And you can see first here, you can see, well, a master clear is present. You can see that port A here is now port A0/AN0, analog 0. In the 84A, we did not see /AN0. Now these pins, the port A pins, are shared with the analog to digital converter. So that's why, if you remember, in all our class demos, when I did not ever use port A. And the reason why I'm using the 77A controller, which actually is sharing these pins with the analog to digital converter pins, and by default these pins are set to analog, okay, not digital. So I was not able to use them directly. So I always said pretend that port B or C are port A, and I used port C. Okay, we have port E here, port E, and these pins are also shared with other functionalities we'll talk about later. We have port D, and these also are shared with other functionalities. And port C, we did not have port C aslan in this 84A controller. We have port C now, and port B was there before. So the first difference is we have more ports. I'm going to talk about these ports and how they are shared with other peripherals. Right. Now, this is the architecture for the 73A controller, okay? But we're talking about, you know, this chapter in the book covers 73, 74, 77, okay? But if you look at the main, I don't know if the data sheet has the 77A one. What did I do? Keep. Let me just check it real quick. I'm not gonna, if it's gonna take me a lot of time. It's gonna take a lot of time. I'm gonna just work on that one. Okay. What is this? This is the 7376. This is the 77. Yeah, here we got it. So the 16F877A controller. See, we still have the flash memory, the program memory. We have the program memory here. Now this is 8K. It used to be 1K. This is 8K. We still have the program counter that is 13 bits. It used to be 13 bits. Mashi. The program memory also is 14 bits, which means, sorry, 14 bits, which means that every instruction machine code is 14 bits. The stack is 8-level stack, so you can push 8 times. Yani a subroutine can call a subroutine, and inside it you can call another subroutine, and so on. This can take 8 values of the program counter. The RAM used to be 68 bytes, now 368. It used to be 2 banks, bank 0 and bank 1. Now we have 4 banks, bank 0, bank 1, bank 2, bank 3. Okay, I'm going to talk about this more, but the same concept, okay? The memory addressing of data memory is direct addressing, where you have the address of the memory location you want to access part of the instruction, or indirect, which is placed in the FSR register, file select register. We have one accumulator with the W register, exactly the same as the 84A controller. The power up timer, the oscillator, power on reset, watchdog timer are all there. Now, in terms of CPU, clear. In terms of CPU, sorry, in parallel ports, we used to have the parallel port A and B. Now, A is there, but the pins are shared with other functionalities. Port B is as is. It used to be shared with the external interrupt for port B0. Port C is new, and its pins are shared with multiple functionalities. Mainly port C, 6, and 7 are shared with the serial communication pins and other pins for the CCP, the capture compare PWM peripheral. Port D is totally new. Port E is new, and we can use it as digital or analog or other functionalities. We have more timers here. Chapter 6 was all about timer 0, and you saw, sorry, was about timer 0, and you saw how useful it is. It was an 8-bit timer. Now we have 2 more timers. We have timer 1, a 16-bit timer, which means that you can count instead of the 8-bit timer used to count from 0 to 255, right? So to adjust your timing, your overflow, we were able to do that using either deciding where you start from to count, or playing with or changing the clock source. Or if you want longer times, we had to introduce software timers, right? Now, timer 1 is a 16-bit timer, which means it counts up to 2 to the power 16, yani 64K. How it can count to 65,536, while timer 0 can only count to 255. So you can produce more time delays using timer 1, same concept. Timer 2 is an 8-bit timer. However, timer 1 is also shared with some functionalities with the CCP, the capture compare PWM. And I talked what the idea what CCP is at the beginning of the semester. We have serial communication ports, synchronous and asynchronous. We have 10-bit analog digital converter, and I talked about that at the beginning of the semester, but it is covered going to be in detail in chapter 11. Chapter 11 is all about this analog digital converter. طيب. These are the main features in the architecture, يعني the main differences, but overall the structure is almost similar when you want to program how to fetch a program, an instruction, execute it, access data memory, and so on. طيب. The other difference, so this was quick. The other main difference, if you remember the status register, this is the status register. It's the same one that we used in the 84A controller. We have these same 8 bits in the status register. We're talking about the status register that is present in address 3 in data memory in both banks. We had a carry flag, a digit carry flag, a 0 flag, all the same concept. Timeout and power down bits that give us indication about a watchdog timer expired, or how did we start up, or we woke up from sleep, whatever. And these 2 bits, PR0 was used to be the bank select bit, PR0, and it used to be 0 or 1. Bank 0, 0 for bank 0, and 1 for bank 1. Okay, and we used to say these are unused, these 2 bits. Now they are used. Okay, now they are used. These 2 bits now in the 77A controller, PR0 and PR1, are combined together and used to generate 4 combinations. 0, 0, you select bank 0, 0, 1, bank 1, 1, 0, bank 2, 1, 1, bank 3. So we have 4 banks now, selected by 2 bits. And these are, this bit is a bank select register in the indirect addressing mode. If you remember the indirect addressing mode, the file select register or INDF register, okay? I'm going to concentrate here, just introduce the concept of the new banking system. And the program memory. طيب. This program memory map is for the 873A. I'm going to go directly to the 77A and discuss the differences. So I'm going to open the data sheet for the 77A and compare it and remind you how it used to look in the 84A. In the 84A microcontroller, okay, let me try to open it again. This is the 84A, this is the 77A. Okay. If you remember, this was the program memory. I'm zooming in شوي عشان نشوفه. If you remember, this was the program memory for the 16F874A controller. We used to have, it starts from here, صح? From address 0. These are the stack, right? Program counter, 13-bit, can be pushed to the stack. And the program memory, which was 1K, but we had an address space for 8K. طيب. Used to start from 00 hex, where the reset vector is. 04 was also reserved for the interrupt vector, and we used to write our program here up to 3FF hex. 3FF hex, how many bits are ones here? F is 4, another F is 4, and 3 is 1, 1. So 8, right?
10.
10 bits, right?
Yes.
Yes. 2 to the 10 is قديش? 2 to the 10 is 1K.
1K.
So this is the actual 1K. And everything else here until 13 ones, which is the address of the program memory, were unimplemented. This is for the 84A controller. Now, what's the difference between the 84A controller and 77A controller? This is the 73, this is the 77, okay? The 77A controller, look at it, how it looks. we see pages now. طيب, let me remind you of something. خلينا نخربش شوي هون. Remember the instructions, the go-to instruction. If you go to the instruction set in chapter, I forgot 4 maybe. Go to K or call K. And we said K, when here it's an address, 11-bit address. 11-bit address. What does this mean? So when you are in the program memory, highly programmed memory, you can write an instruction here, a go to address, I don't know, go to location 1. Location 1 could be here, مثلا. Location 1 could be here. This address has to be 11 bits. 11 bits. 11 bits cover 2 to 11 locations, right? Yani 2K. Which means the address 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, these are 12 bits, right? The address has to be 11 bits. Which means you cannot move between memory locations that are more than 2K locations away, 2048 locations further than each other. طيب. Starting from 0, so let me draw the map. So if this is the program memory, program memory. We know that the address, the location, the content of a program memory location is 14-bit, right? We know this, which is the instruction side. However, the address is 13-bit, right? And this matches the program counter, by the way, right? 13-bit. So you start at address 0, right? 0. But our actual instructions did not take more than 11-bit address, which is up to 2K. The actual implementation was only for 1K. But here in the 84A controller, 2K is, يعني لو بدي أجي هون أعمل 11 bits. So from 000, 13 bits. 13 bits will be, let me try this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These are 12, 13, صح? So from 11 zeros, 4, 8, 0, 0, 0. These are 11, صح? 11 bit. في 0, 0, 1. هو total 13. يعني 11 plus 2, 13 bit. So you start from 0. You go up to 0, 0, and the other 11 bits are ones, right? 1, 1, 1. Then we have 1, 1, 1, 1. 1, 1, 1, 1, right? And this is F7, صح؟ هيك 0. تمام? So the address here is going to be 0x07FF. And these are 2 kilo words, 2048 locations of instruction size. If we continue, we said we have 8K. The memory location right after the 7FF is going to be 0 increment 1 0 1 بعدين 0 0 0 0 0 0 0 صح 0 0 0 0. So the location right after this is going to be what? 0 0 8 0. So it's going to be 0x 0 8 0 0 up to 2k 11 bits change up to 1 1 1 1 1 1 1 1 1 1 1 1 0 صح يعني هذول ال 8 changed only 4 هذول ال 11 sorry 11 bits. So this is going to be f so yeah with this high f high 0. So the last location is going to be 0x 0 3f's, and these are also 2k locations 2k. So we have first 2k, second 2k. Then we continue counting. The address right after this is going to be 0x1000, right? Yeah, 1000. طيب. Which is what? 1 يعني 0 0 0 0 0 0 0 0 0 0 0 0 1, right? هذا first location here. Count until 1 1 1 1 يعني 11 ones 1 1 1 1 1 1 1 1 1 1 صح؟ لا 11 ones is 4 8 high 11 here high 11, so high is going to still stay at 0
0 1.
Yes, 0 1. So this is 0x high f high 7 high 1. So 0x 1 7 f, right? The memory location right after it is going to be, add the 1 to this, يصير 0 0 0 0 0 0 0 0 0 0 0 1, right? 1. So the address of the beginning of here, طبعا high 2k. The beginning of the next 2k is going to be 0 0 8 1. So 0x 1 8 0 0 up to, and we're done, up to the last memory location, the 11 bits here, right? The 11 bits هذول 11 bits become ones, right? So 1 1 1 1 1 1 1 1, and then 3 zeros become a 1, and 1 1 stay as is. So this is f 1. So the last memory location is here 0x1 f, right? And these are also 2k. 2k, 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 2k. These are 2k are 8k. And if you look at this in blue, يعني لاحظ لي here, all the memory locations within these 2k start with 0 0, right? All the memory locations within these 2k start with 0 1. All memory locations within these 2k start with 1 0, right? All memory locations in these 2k start with 1 1. ماشي? So 0 0 is page 0. 0 1 يعني 1 صح? Is page 1. And 1 0 is 2 صح? So this is page 2. And 1 1 is in binary is 3, so this is page 3. تمام? Then the most two significant bits of the address, the 13-bit address, decide which page we are in. Understood?
دكتور
Ah.
أنا لازم أروح عشان عندي امتحان.
Okay, you can leave. I'm gonna end here, بس يعني final touches. Okay, you can watch the last few minutes in the recording. Okay. Okay, so a 13-bit address, of program memory. The 11 are used to move within the page itself. And here, this is the 7.3, it has only 2 pages. But if you look at the 7.7A in the data sheet, you see the 4 pages. This is what we just did on the board. ماشي? So the first 11 pages, the first 11 bits of these 13 bits are to decide which location within a page. ماشي? But the last 2 bits decide which page you are in. So let me say, let me do this. Assume we have a location here called 0x0020. ماشي? Address 20. Address 20, let me ask the question. Address 20 in page 0 versus address 20 in page 1. What will be the actual address? طبعا, for a program here, if I have an instruction say go to 20, it will go to here. But if the instruction is written here, go to 0x20, it's going to go to this 20. ماشي? It's not going to jump to another page. It's going to go to here. Because your most 2 significant bits here are 0, 1, and they're going to stay 0, 1. And the 20 is going to translate into the 11 bits. So the 20 in page 0 will be 20 is 0, 0, 0, 0. 2 is 0, 1, 0, 0. هاي 8 bits, right? Then you continue. We are in page 0. يعني هاي 1, 2, 3, 4. 1, 2, 3, 4. 5, 6. هاي 8. يعني 8. 9, 10, 11, 12, 13. The last 2 bits are the page number, right? Which is page 0. So this will be 0 if we're in page 0. وبعدين هذول zeros. تمام. While the 20 in address in page 1, خليني أكتبها بالأحمر أحسن ما أكتب من جديد. In page 1 is going to be exactly the same 20, 0, 0, 1, 0, 0. ماشي. But the last 2 bits will be 1. يعني 1 is يعني 0, 1 صح? 0, 1 in page 1. So the actual physical real address for this location is 0, 2, 0, 0 صح? 0x 0, 0, 2, 0. This is in page 0. While the one in page 1 will be what? 0x. لا مش نفس الشيء. هاي راح تكون 0, 2, هاي 8, هاي 0. So it's going to be 0, 8, 2, 0. ماشي? If it was in page 3, page 2 it will be 1, 0 آخر 2 bits. Page 3 will be 1, 1. وهذول بيكونوا the same. Okay? So if it was address 20 in page 2 will be 0, 2, 0, 1. يعني راح يكون 0x 1, 0, 0, 20. Sorry. راح يكون 0, 0, 0, 0, 0, 1, 0, 0, right? هاي 8 bits. Then 00001, right?
Yes.
Yeah, so it's going to be 1 0 2 0. Hi, page 1. Page 1. 2, sorry, page 2.
Page 2.
Page 3, it will be like this: 0 0 0 0 0 1 0 0 بعدين 0 0 0 هاي صاروا 4 8 صح
0 2
11
8 1.
بعدين 1 1 صح. So the address is going to be like this: 0 2 8
8 1.
1 صح. So it would be 0x 1 8 2 0. So the address 1820 or 1020 or 820 or 020 are all address 20 but in different pages. تمام? So if I say go to 20, why my instruction, my go to 20 is here, it's going to go to this 20, not to this 20. Okay, what if I want to go to this address location? How do I do that? We'll answer this question next time, because the go to, we cannot give it more than 11-bit address here, okay? This is the structure of the instruction. So we need to access the most 2 significant bits of any address, and we'll learn how to do that next time. Thank you very much. Sorry, بس يعني I wasn't able to stop in the middle. Stop recording, and we'll continue next time. Thank you and see you Thursday.
يعطيك العافية دكتور.